Hey guys, these are our notes. I'm officially starting Unit 1. So today we're going to be talking about normal distributions. You can grab a piece of paper at the top, put your title, Notes 111, Normal Distribution. The first thing we're going to talk about is there's two types of data that you can see, discrete and continuous. Discrete just means that your values are going to have gaps in between, so it's just a set of values with gaps between the numbers. So for example, rolling a die would be a discrete set of data because you can roll a die and get a 2, you can roll and get a 6, but you can't roll and get a 2.5 or a 3.9. You can get a 1, 2, 3, 4, 5, 6. There's no nothing in between those numbers. Continuous data, on the other hand, you have at least one value between your numbers, so it's just a set of values with at least one value between numbers. One value. So for example, that could be like people's height. There's somebody that could be 61 inches tall, 61 and a half, 62, 62.39 inches tall. There's like numbers in between those inches. Okay, so the first thing we're going to talk about is uniform distribution. I know our notes are titled normal distribution, so there's one that's the normal distribution and one that's the uniform distribution. So the uniform distribution is just a set of values that are continuous. They are symmetric to a mean, and they all have equal frequencies. So it's just a set of values that are continuous, symmetric to a mean, and have equal frequencies. So if you made a bar graph, a pie chart, whatever it is, okay, whatever your data are, it would look like a rectangle. That would be a uniform distribution. They all have the same exact frequency. They all go up to the same amount. They're continuous. It's symmetric to the mean that's in the middle. So this would be a uniform distribution. In order to find the probability of outcome, so I know that I think you had to skip this unit last year in Math 2, but the way that you find the probability, right, P of your A, whatever you're trying to have happen, you always make a fraction. On top it's like what you're trying to find, like whatever it might be, and then on the bottom is like the total number of outcomes you could have. So on top you put the width of interval of interest, and on bottom you put just the total width of the interval. So we're going to go do an example of this right now. So you're going to go ahead and get your workbook, Unit 1, open to 1.1.1, which is on page 13. And we're going to do example 1. So example 1 says find the proportion of values between 0 and 1 in a uniform distribution that has an interval from -3 to 3. Okay, so number 1 is sketch a uniform distribution and shade the area of interest. Okay, so a uniform distribution is going to look like a rectangle. It says the intervals from -3 to +3. So here's 0. We're going to go +1, 2, 3. And then -3, so 1, 2, 3, -3, -2, -1. And then we're just going to draw that as a rectangle. Well, our area of interest, it says find the proportion of values between 0 and 1. So here's 0, here's 1. That's our interval of interest. So step 1 or 2 says determine the width of that interval. Well, this interval, okay, if we broke this up into like as if it was like a histogram, bar graph, or whatever, I only shaded one of the little pieces. And then the total width, as you count, there's 1, 2, 3, 4, 5, 6 of them. That's the total for number 3. So if we want to set up the proportion, we shaded 1, there are 6 total. Then that's our probability of the outcome. It's just 1/6. Okay, so you're going to go do some homework problems that have to do with that. You're going to go to those now. It's on page 18. You're going to go do numbers 5 and 6, and then you can come back and finish your notes. So then for the rest of our notes, the next thing we're going to talk about is the normal distribution. Okay, so that's what the notes are titled. That's what we're going to talk about is the normal distribution. Oh, you know what? Did we have another example? I messed up. I'm sorry. We're going to go do example number 2. This was on page 14, so if you flip it over. It says Madison needs to ride a shuttle bus to reach an airport terminal. Shuttle buses arrive every 15 minutes, and the arrival times for buses are uniformly distributed. What is the probability that Madison will need to wait more than 6 minutes for the bus? Okay, well, it says that they arrive every 15 minutes, right? So that means that if she's waiting for the bus, she could wait in 0 minutes. It could be there. She could wait 1, 2, 3, 3.5. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But the most she'll wait is the 15 minutes for the bus because it comes every 15 minutes. It says, what is the probability that Madison will need to wait more than 6 minutes? So here's 6 minutes, and she has to wait more than that. So any of these times would be more than that. So to make our probability, for probability of more than 6 minutes, we have to make a fraction. On top, we count how many pieces we shaded, and on the bottom is how many total pieces. So there's 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces that are shaded. And then there's a total of, if we count these pieces, that's 10, 11, 12, 13, 14, 15. There's 15 total pieces. We can simplify that fraction. So if you were taking a test that was like multiple choice or anything like that, they would reduce it to 3/5. You could also see it written as a decimal. That'd be 0.6. That's also a probability. Or you could even see it as a percentage. 0.6 is 60%. So what is the probability? There's 3 different ways you can give probability. You can give it as a fraction, you can give it as a decimal, or you can give it as a percentage. Those are all probabilities. So now you would go do page 18, numbers 5 and 6. Let's go back, and now we can finish our notes. Sorry about that. Okay, so normal distribution. The normal distribution is not going to look like a rectangle. The normal distribution is going to look like what we call a bell curve. It's just a symmetric curve that is clustered around the mean. And tapered on both sides. Okay, so what it's going to look like, the normal distribution, it's going to be a normal curve, so it kind of looks like this. You can draw it as best as you can. In the very middle, you're going to have your mean, that's mu, and then you're going to add 1, 2, and 3 standard deviations to the right, and then you're going to subtract 1, 2, and 3 standard deviations to the left. So the 1, 2, and 3 standard deviations to the left, remember standard deviation is a measure of how spread out your data is. The smaller your standard deviation, the more clustered. The bigger your standard deviation, the more spread apart. We need this 1, 2, and 3 standard deviations for something called the empirical rule. For the empirical rule, you need to remember 68, 95, 99.7%. So with the uniform distribution, to find our probability, we could just count like how many of the little, bars, whatever, from a bar graph or whatnot, you had. For a normal distribution, we're going to look at what happens when you have your normal curve. So here's my normal curve. So remember, in the middle we have the mean, and then you're going to add 1, 2, and 3 standard deviations to the right. Plus. So that's the little standard deviation symbol. And then you're going to subtract 1, 2, 3 standard deviations to the left. In between -1 standard deviation and +1 standard deviation, this whole little area right here, that shaded area is 68% of your data lies in there. So hypothetically speaking, we had like a little bar, a little dot plot like this. 68% of our data would lie in that little section right there. So that's what it means, is that 68% of our data is going to fall between 1 standard deviation above the mean and 1 standard deviation below the mean. Then the next rule, so see how it says 68, 95, 99.7. So the next one is we have our normal curve. I didn't draw that very good. So in the middle we have our mean, and then you're going to add 1, 2, 3 standard deviations to the right. You're going to subtract 3 standard deviations to the left. In between -2 standard deviations and +2 standard deviations, so if you add 2 standard deviations and subtract 2 standard deviations from the mean, that's going to hold 95% of your data. So 95% of your data should be within 2 standard deviations up and down from the mean. So the last one, you should hopefully be able to guess our percentage and what we're going to do. So for our normal curve, that one's not very good either. Man, I just keep getting worse. Okay, so your mean's in the middle. You're going to add 1, 2, 3 standard deviations to the right. You're going to subtract 3 standard deviations to the left. In between plus and minus 3 standard deviations, this right here should hold 99.7% of your data. So it's not 100% of your data. There could be like a little outlier, somebody who's more than 3 standard deviations below or more than 3 standard deviations above, but the majority of your data, 99.7% of your data, is going to lie between plus and minus 3 standard deviations from the mean. So that's the empirical rule. We're going to go do a couple examples back to page 14, example number 3. It says temperatures in a carefully controlled room are normally distributed. So notice how it says normally distributed. So our other one said uniformly. These ones say normally distributed throughout the day with a mean of 0 degrees. So we have a mean of 0 degrees and a standard deviation of 1 degree. Shane randomly selects the time of day to enter the room. What is the probability that temperature is between -1 and +1 degrees? So first let's start by drawing our normal curve. So draw our normal curve. In the middle is our mean. Our mean is 0 degrees, so we're going to put 0 in the middle. And then we're going to add 1, 2, 3 standard deviations to the right. Well, the standard deviation is 1, so I'm just going to add 1, add 1, add 1. Then I'm going to subtract 1, 2, 3 standard deviations to the left. So I go 0, -1, -1, -1. So between -3 and 3 degrees. So it says that Shane randomly selects a time of day to enter the room. What is the probability that the temperature is between -1 and +1? So here's -1, here's +1. We want to know the probability that the temperature is between those two numbers. Well, this is -1 standard deviation, this is +1 standard deviation. Well, we had the empirical rule says that 68% of your data is going to lie between plus and -1 standard deviation. So this little section right here, the probability that he goes into the room and it's between plus and 1 degree Celsius, not Fahrenheit, is 68%. So if it had been between 2 standard deviations, plus or minus 2 standard deviations, it would have been 95. If it would have been plus or minus 3 standard deviations, it would have been 99.7. But it was between -1 standard deviation and +1 standard deviation, which means it's 68%. All right, last one. It says the scores of a particular college admission test are normally distributed. So we see that normally distributed. Has a mean score of 30 and a standard deviation of 2. Let's draw it first, and then we'll focus on what the question says. So the way that you draw it, okay, you put your curve. You put your mean in the middle. So my mean is 30. Then you're going to add 3 standard deviations to the right. My standard deviation is 2. So it means I'm going to add 2. 30 plus 2 is 32. Add 2. 32 plus 2 is 34. Add 2. 34 plus 2 is 36. Then I'm going to subtract 3 standard deviations to the left. So I'm going to subtract 2. 30 minus 2 is 28. 28 minus 2 is 26. 26 minus 2 is 24. So the question, now we'll go read our question. It says Erin scored a 34 on her test. So 34 is right here. That's the 2 standard deviations, right? Here's the mean, 1 standard deviation, 2 standard deviations. If possible, determine the percent of test takers whom Erin outperformed. So these people did better, they got a higher score, but she outperformed all of these people to the left. So we're gonna try to figure out what percentage she outperformed. Okay, well, there's a couple different ways we can do this, but one way is we could look at, okay, well, right here, the mean is the center. It's not very centered on my curve, but this piece right here would be 50% of the data. From the mean less, that would be 50% of our data. So that means that she outdid 50% plus whatever this piece is right here, okay? So whatever that piece is right there. Well, this is 2 standard deviations, right? And then over here, this would be 2 standard deviations. So between here and here, that piece right there from the empirical rule is 95%, right? From minus 2 standard deviations all the way to plus 2 standard deviations is 95%. Well, we only want half of that because we're going to cut it at the middle. So if we take half of that 95%, we can go ahead and find this piece right here. From the blue line to this line. I should have switched colors, but from the blue line to here, we're going to find this piece by taking half of 95, because from -2 to +2 standard deviations, it's 95% of the data lies under the curve. So then we're going to add 50 plus half of 95. How do I know? I think it's 47.5. And when you add those together, you get 97.5%. So determine the percent of test takers whom Erin outperformed. Erin outperformed 97.5% of test takers. I should have written that sentence. Erin scored higher than 97.5% of the test takers. So there are 2.5% of people did better. They scored like a 35 or a 36, but you know, only 97.5 is how many she did better than. Okay. All right, we need to put these notes into our digital notebook. It goes on slide 8, 9, and 10, and then you can go finish the rest of the problems, page 17, 1 through 4, and then page 18, 7 through 10, and that's it.